All right, so it's week 2. Thank you to everybody who has been doing their work every day. We've had around 70 people that have completed all of their work. Everybody else, what are you waiting for? You know you've got to be bored at home right now. So, this week we're going to be working on different kinds of graphs. Here's the warm up. I'll scroll down to number 4. Try to use no calculator on all of the warm ups this week. And when you're done, go to the next slide. Okay, number 1. The first thing I did here is I wrote down the information I was given, that the area was 1/2 and the width was 1/4. And because I know it's a rectangle, the only formula with area and length and width of a rectangle is area equals length times width. So then I just plug the numbers in. 1/2 is the area, 1/4 is the width. It's a one-step equation, length times 1/4. So in order to solve for the length, I divided each side by 1/4. So the problem I actually did is 1/2 divided by 1/4, which gives you 4/2. Now all week today, number 2 is going to be an order of operations problem. So I've wrote it off to the side here. Order of operations, first comes parentheses, then exponents, then multiplication or division, then addition, subtraction from left to right. So if you look at the problem, the first thing that needed to be solved is 8 divided by 4. Multiplication and division are on the same line, and they go left to right in the problem. So I had 12 minus 2 times 3 plus 2. From this line of math, I have subtraction, multiplication, and addition. I still have multiplication I have to do, the multiplication, then the subtraction and addition to get to 8. Number 3, Jessie babysits to earn money. We have some information. We know she charges $6 for the first hour and $5.50 for each additional hour. So if she worked for 2 hours, it'd be $6 plus $5.50. If she worked for 5 hours, it'd be $6 plus $5.50, $5.50, $5.50, $5.50. So the correct equation for number 3 is here. 6 plus 550n, and n is the number of hours she works. So number 4, the distance between -3 and 4 and 2, 4. This is simple. I lined up my 2 ordered pairs. My y values were the same, so that's not going to help us. So on our x-axis, to go from -3 to +2, all you have to do is count the units. 1, 2, 3, 4, 5 units. So those 2 points are 5 units apart from each other. The daily dose this week is going to be inequalities. At this point, you should pause the tape and put these 4 signs and the words into your notes. So number 1 says the Hornets need to win more than 5 games to make the playoffs. Write an inequality to show the situation. Well, more than 5 is important. That means they can win 6 and make the playoffs, 7, 8, 9, 10. But if they win 5 games, they won't make the playoffs. They need more than 5. So the number of games needs to be greater than 5. On the bottom, to go to a party, a student needs to have had less than 6 days of CDP. Less than 6. So that's like 5, 4, 3. So less than 6. Okay, today the LEQ is how is a statistical question determined and how can the answers be analyzed? And there's a link to a vocabulary video. If it doesn't work on your Chromebook, you can always go to YouTube and just YouTube vocabulary statistics and the movie will come up that way. It's a short little song that'll help you to remember some key terms. So, statistical questions, and this is for your notebooks. Statistical questions are questions that generate a variety of answers. For example, if I am asking the question, how old am I? How old am I? There's only one answer to that question. There will not be a variety of answers. But if I ask, how old are the kids in my school? Well, some kids are 10, 11, 12, 13, 14. So statistical questions that are able to generate a variety of different answers. The first one, how old am I? There's one answer. It's whatever age you are. How old are the kids in my school? There is a variety of those. So, on the left-hand side, we have some statistical questions. What is the favorite color of the kids in my school? So kids could say blue, red, purple, magenta, orange. They will have a variety of answers. What countries are students at Coolwood from? United States of America, Mexico, Honduras, Senegal, a bunch of different countries. Questions that are not statistical questions. How old is Mr. Mackey? There's a specific age. How tall is LeBron James? There is a specific height. There is only one answer to those questions, not a variety. So here's a quick some examples. Just go ahead and jot down statistical or not and think about your reasoning behind it. You can pause the tape whenever you're ready before we go over them. Okay, the first one, what is my math test score? That is not a statistical question. It will not generate a variety of answers. You have one score. What is the height of each person in my class? Yes, that is a statistical question. Why? Well, because there will be different answers. Not everybody in the class is the same size. How old is Mr. L? That is not a statistical question. He has one age. It will only provide one answer. What is Miss Coloretta's favorite football team? That is also not a statistical question. She will have one team. How many pets are owned by the students in 6th grade? Yes, that is a statistical question because some students could have one pet or two pets or 6 pets or 0 pets. It will generate a variety of answers. Now, we represent statistical questions in a couple different ways. Here are some of the most common ways that you will see. On the left is a dot plot, and each one of those dots represents a response. So if this was the number of minutes a student reads each night, we would see that 3 people said 15 minutes. We would see 2 people said 50 minutes. And just by looking at it, we can kind of make some generalizations, like the greatest amount of 25 minutes and 40 minutes were the most common amount of minutes that people read each night, if that's what the graph was displaying. Down here we have a histogram, which is what we're going to be looking at pretty much today. Histograms are similar to box plots, except you see at the bottom there's a range. So this is not just 1. This is 1 through 5. This is 6 through 10. There's a small range. And then later on in the week, we are going to look at box and whisker plots, which are kind of interesting. And there's just a quick example of a box and whisker plot there. Okay, there are some key terms here that you definitely want to put in your notebook. So if this graph were about the number of students who own pets, how many they have, here's what the graph could look like. There are some key features to this graph. Where everything or most of your data is located is called a cluster. There is a cluster of the data there. An area where there is no data is called a gap. And if there's 1 or 2 all by themselves, they are called outliers. Go ahead and take a minute and pause the tape and get this into your notes. Okay, so here's a dot plot that shows the data from the question, the number of hours watching TV per week. And a class was asked this question, and here were the responses. So as we look at this, the first thing I notice is most of the data is right here. That's where the cluster of our data is. We do have a gap, and there is one person that is an outlier. That's answer was a lot different than anybody else's. So we can actually get a lot of information from this. Like if we needed to know how many people were surveyed, in a dot plot, each dot represents a person. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There's 28 people in this class that took this survey. And it would be safe to say that most people watch less than 15 hours of TV because almost all of the responses are less than 15 hours per week. We could say that one person watches much more TV than everyone else. This person out here watches between 35 and 40 hours of TV, which is significantly more than any of the answers down here. So statistical questions, not only do they generate a variety of answers, but then those answers can be represented on graphs and charts. Okay. So here is a new dot plot, and this is a similar question. This was asked of a different class. How many minutes of exercise do they get per day? And here were the students' answers in the dot plot. when you get a chance, pause the tape and start thinking about these two questions. How many people were surveyed, and what was the most common amount of time exercised each day? Okay, so when I look at how many people were surveyed, that's simple. I counted up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there were 22 people in this survey. The most common amount of time exercised each day, the most common, well, right here, 45 minutes. The most people chose that as the number of minutes they exercise per day. And I didn't have to do any math. All I really had to do is take a look at the graph. And if I was going to describe this graph in my own words, I would probably say it skews or leans to the right. And I would say that most people watch 40 to 60, most people do 40 to 60 minutes of exercise per day. Okay, here's the bit.ly for today. It's bit.ly/statquestion. When you're finished, enjoy the rest of your day and come back tomorrow for day 2.